We're doing the Proctor Compaction Test, which is done to British Standard 1377 Part 4, and you can see we've got the equipment laid out here. We've got the steel mould here, which we've got, I'll put up here, I'll show you, take the dimensions to get the volume of it. We've got the sheet from the British Standards here, which shows us all the different calculations and different things we need to be solving for and working out for. So we start with taking the dimensions, the inner diameter of the mould, and also get the height. We've already pre-populated this and just talk you through this just now. So first of all, working out the volume of the mould, pi r squared, the area times the height gives us the volume. Height of 11.5 millimeters, diameter of 10.5 gives us a radius of 0.0525 meters, so we've got our volume. Then we've got the mass of the mould, which we weighed on the scales here. So this is empty mould plus the base. 3.405. Mark it up here. And this is going to be used when we're working out our density later on. So I'll put this back in the tray.
And this is the colour that accompanies the mould, so it just sits on top like so. So what we do is when it comes to filling the mould, we basically fill it in thirds. So the mould itself consists of the bottom section, top section here, there's 50mm colour. It's just there to basically contain any material that may overspill out of the mould itself. So the next stage then, that you'll see on our results, is we've got the initial mass. So the initial mass is the mass of the dried sample that we're going to be testing today for this particular test. So this has been oven dried. And what we'll do is we'll just confirm the results we've got on the board there by putting it on the scale here.
Yeah, and we've removed most of the large granular material from it already, which is important for the compaction testing. So what do we have?
So we have an initial mass of 2.656. So we'll just change that on the board. So that's our initial mass. That's the sample dried, so zero moisture content. So what we've worked out is we're going to go up in 2% increments for the moisture content, which has been calculated previously. So our moisture content, so for a 2% increase in moisture content, we've basically 2% of our initial mass, which is our 2.656, which we'll just recalculate just now, which will then give us a value of somewhere in the region of 0.0553 kilograms. So each time we test, we'll increase the moisture content by that given mass. So what we'll do, we'll take the sample now, we'll now test this dry. This is going to be in the 0% moisture content column. So what we do is we fill the mould up a third each time. So this bottom section, which is the mould, just make sure everything's nice and clean, so we're getting a nice accurate set of results as we go. Everything's nice and tight there as well. So what we'll do, I'll fill this up 1/3, and then this is the 1 litre mould. So you get this one, which accompanies this here accompanies this particular test. This is a 2.5 kilogram rammer. So basically this is the length in which it falls freely is 300mm. So that's defined within the British Standards. So this is a 2.5 kilogram rammer. So you also get a 4.5 kilogram rammer, which is used for other tests where you might have like larger aggregates within the sample size. So what we're going to be using today is the 2.5 kilo rammer. So this basically requires 27 tamps from the rammer itself per layer. Okay, so 27 for this particular rammer. If we were to use the 4.5 kilo rammer, or if the aggregate size is larger than what we've got, so if it's larger than a certain percentage over the 20mm aggregate, 62 blows per layer. So what we'll do is we'll start off filling this mould up 1/3. So we'll scoop here. And we'll try and contain as much material as possible, so we're not losing anything as the test proceeds. So that's 1/3, approximately in there. So 27 times with the rammer. So just lift it up each time, let it fall freely into the sample. Nice even kind of distribution around the sample itself. And I've lost count. So fill up another 1/3. And then again, 27. And then finally we'll just take it up above the mould itself for this final sample. And then what we'll do, once we've done the 27 times with the compaction, we'll take this top collar off, screed the material down to the top of the mould itself, and then we'll determine the mass that we've got within that mould then. So another 27. Process now. So what we're going to do is we're going to remove the collar. And we'll place this in here just to capture as much material as possible. And as you can see, there's a couple of voids there, so we'll just fill them in before we measure, before we weigh the sample. There's a couple of voids in here, so I want it nice and flush with the top of the mould. This material is really dry, so there's no kind of cohesion in it at all. So we just want to make sure that all the kind of voids that are visible are filled. And then if my assistant is passing me the brush, we'll just brush off the excess material. And now we'll weigh the sample to see what we've got. So in this case, for this first one, we've got a mass of 5.328 kilograms against our 0% moisture content. So what I'm going to do now is I'm going to basically tip this material back into the tray, and then I'm going to add some water to increase the moisture content by 2%. again, keeping the mould as clean as possible to try and get a true set of results. So what we'll do now, take it back over to the balance, and then we'll increase the moisture content. So we're going to have to increase this by 0.0553. Just trying to keep it, kind of distribute the water as evenly as possible throughout the sample. Makes it easier for mixing it together to keep everything kind of consistent, uniform throughout. So there we go. So what we'll do now, we'll just mix this up. So all the soil should hopefully be of a consistent moisture content. Trying to keep everything in the tray so we're not losing any of our sample that we're testing. So we've chosen 2% increments each time. This is what it specifies in the British standards for a granular soil. So this is quite a sandy soil, sandy material. So there's kind of no cohesion in here at the moment with this sample. So if there was some cohesion, then it suggests that the moisture content increases by somewhere between 2 and 4% each time. So we've just chosen the 2% increments for this particular sample that we're testing today. So you can see quite a uniform colour throughout, and distributed the moisture. So again, what we'll do, repeat the process, fill the mould up into thirds, and compact them each layer 27 times using the rammer. So let's put the collar back on to begin with. Secure that in place, and then first third, and then 27 with the rammer. And then second third. So into the mould it goes. So you can see the kind of consistency of the material is starting to kind of bind together a wee bit more, which is typically what you would expect. So we're wanting basically that addition of moisture is kind of lubricating the soil granules, making it easier for the particles to basically rearrange themselves to give a better compaction. So 27 again. Final third for this moisture content of 2%. So what we're hoping to achieve in this test is we want to try and find the optimum moisture content for this soil. So each soil will have an optimum moisture content to achieve its compaction. So that's the purpose of this test, is to determine at what moisture content would that be. So I've filled this up now. I'm going to add a little bit more in there, so we're definitely beyond the height of the mould. And then 27 times again. So what we do again is shift this into the tray to capture any material when we remove the colour. Just slacken that off, just to clean that, if there's any residue. And then just finish this off, just make sure it's flush with the top of the mould. So again, there's just a couple of voids in there. Just want to fill in. It's okay. So what we'll do now is we'll weigh this, see what we've got. So there we've got this time 5.360, sorry. And again, what I'll do is I'll just tip this back in to the tray. So as you can see, here is the kind of first kind of layer of material. So you can see it's quite well compacted compared to the first sample, which demonstrates that the material is becoming more compacted as we're increasing the moisture content. And we've just got some material here that's actually fallen out the tray, which I'll put back in. And again, what we'll do now is we'll increase the moisture content by another 2% with the addition of 0.053 kilograms of water. So just again distribute that evenly over the sample. Makes it easier to mix in, to give us a consistent moisture content throughout. Try and get it as accurate as possible. So here we go. So what we'll do now, again, we'll just mix this up, make it nice and consistent throughout, and repeat the process. Here we are back again, so we've now reached our, this is now 12% moisture content. So we basically increased it 2% up until 8%, and now we've just decided skip 10 and go to 12, just for the kind of time constraints for the video. So hopefully with the 12% we've gone beyond our maximum dry density for this particular soil. You can see the type of soil has changed here. So you can see now that the kind of consistency of the material itself looks different, it's changed. So it's gone, kind of turned into more kind of a liquid form.
Cohesive.
So you see the moisture now rising to the top. So hopefully with this one, what we'll expect is when we do the calculations, we'll expect the dry density then to be falling back down. So what we'll do is we'll weigh this one again, and then we'll perform the calculations. So chair the scales, pop this on top. So for this one, we've now got a mass of 5.497. So what we're doing for the third row on this data table is we're basically calculating the mass of the sample contained within that mould. And now we're going to work out the bulk density. So the bulk density is going to be the mass of the sample contained within the container divided by the volume. So the volume we calculated previously. And then from there we can calculate the dry density based on the moisture content for that given sample. So as you can see, we've gone beyond our peak maximum dry density for this particular soil. So what we can do now is we can now plot the results on our result sheet, moisture content against dry density. So what we typically expect here is from our dry density results and moisture content. If we plot this on the graph, what we'd expect is a nice kind of curve. And wherever the peak of that graph occurs, we just take that across, and that gives us our maximum dry density for this given soil. And if we go down to the x-axis, that will then derive our maximum moisture content, optimum moisture content for this sample. So just as an example, sketch out roughly on the board here.
So what range do we have? Okay, so Liam, do you want to read them out that we have?
So for the first one, 0% moisture content, we've got a dry density of 1931.1.
So alphabet there.
For 2% moisture content, we've got a dry density of 1943.
Okay.
4% moisture content, 2.063. So I'm just rounding them up each time to the nearest whole number.
Okay.
6% is 2.092. 8%, 2.129. Sorry, 2129. And finally, for 12%, it's dropping back down, and the dry density for 12% is 2079. So if we now plot draw a line between each of the points, you can see it goes up to a peak, and then it comes back down. So the peak lies somewhere between 8 and 12%. So if you were doing this on graph paper, doing it accurately, we would be able to obtain the exact optimum moisture content for this particular soil.
We're using Excel function
Yeah.
to get a curve that would fit that.
So basically from our results, what we could determine is we can determine the maximum dry density for the soil. So that's the peak of the graph going over to the intersect of the y-axis, and then if we follow the peak down to the x-axis, that gives us our optimum moisture content for the soil. So ideally, if you're in the kind of construction phase of a project, you would ideally want soil to be within that kind of moisture content range to allow it to obtain its maximum compaction.